Hello, here's the short video on adaptive load balancing on QFX10K Juniper switches. So for this test, we're going to use QFX10K. That is going to be device under the test. We will be having a bundle A aggregated link comprising of 4 member links. This is 4 times 10 gigabit. And we will be having Ixia to send different flows and observe what's happening. So when we send, for example, 2 flows without adaptive load balancing, what may happen is those 2 flows can end up on the same member link. So let's see actually that example. I'm going to clear the statistics, and under the aggregating interface A1, I don't have at the moment ALB applied. I have several flows, and these flows are currently suspended. So for example, if I enable 2 of those flows, here is the first flow. By the way, each of 4 flows are 10K packets per second. So if I enable 2 flows, what we see is that they both ended up on the same member link. So one of those links from the picture now is carrying both flows. So let me now apply the ALV. So this is the configuration that we are going to apply. Let's see that here. So the configuration that is going to be applied on the QFX10K switch is this. And what we expect to happen now is that those 2 flows will be distributed among 2 links, 2 member links. So let's see that. And sure enough, the flows are now on 2 different member links, 0 and 3. So if I add 2 more flows, flow number 3 and flow number 4, I expect to see them take another 2 links that are not utilized at the moment. So I will enable 2 flows and we will see 4 member links being utilized. So let's see what happens when we add an elephant flow that is much bigger in bandwidth than the flows that we currently have. So at first, this flow will share its member link with one of the existing flows, but what we expect to happen is that the smaller flow will be moved to another link as the system is trying to distribute as much as it possible of the load across all the links. Although in this example, this is an extreme example, and the number of flows is small, but still the system is trying to distribute the flows as equally as possible across all the links. So let's observe that situation. The elephant flow is here. Once I activate that flow, we will see that in the beginning it's sharing the link with the small flow here. But soon enough, we can see that the smaller flow has been moved to upper link. All the flows apart from the elephant flow are 10K packets per second. So far, we have been observing all the flows that are coming on the same ingress PFE here. But there is a certain caveat with adaptive load balancing implementation, and that is when the flows are ingressing two different packet forwarding engines, there is no guarantee that they will not end up on the same link. In the current implementation, every packet forwarding engine is doing optimization on its own, independently from all the other packet forwarding engines. So what I'm trying to say here is if we have two flows which are egressing to via two different PFEs, those two flows may end up on the same member link. So if we see that situation, for example, I'm going to stop all these previous flows, and then I'm going to enable the flow from the different packet forwarding engine. This is the flow here. And another flow, we will see that they will end up on the same member link. So basically the caveat is that each ingress packet forwarding engine is doing optimization on its own. So the switch is not globally optimized. So if we try to express this mathematically, that probably it would be something like this. What we get with the current implementation is that optimization is done per packet forwarding engine, and that can only reach sometimes the optimization that ideally should be done on the globally, but still this is much better than no ALB when we have just plain simple hashing. So we are currently somewhere in between these two extremes. This is the ideal case. We are currently here. So we are again better than no ALB at all. Of course, the more flows, the better traffic distribution among the member links. That rule is applicable at all times. Thank you for watching.